Hi, we are Group 9, and this is our MAC Graduate Program Database. My name is Molly Rippey.
I am Daniel Jaramillo.
And I'm Marty Bogard. So first, we wanted to address the problem/the business needs. The MAC program needs an updated system that will help organize and easily manage the current data and any data that will be collected in the future. So doing this, we looked through three perspectives. First, we started with the student perspective. And we addressed what courses students have taken, are taking, and will take. Then when they plan to graduate, and how they will meet these course requirements. And the requirements are 6 MAC core courses, 2 of them can be replaced with electives, an additional 1 MAC elective, and then 3 free electives. Next, we looked at it through the course perspective, and just how many students will be in each section of each course each semester, and which courses need to be offered each semester. And lastly, we looked at it through the semester perspective. How many students will be enrolled in each term? There are 4 terms: fall, spring, summer 1, and summer 2. And how many credit hours MAC students will take. And we have MAC students, dual enrolled MAC students, and Xavier employees.
The data given to us by the MAC department consisted of 3 Excel files. The first Excel file was the advising grid. This gave us their student name, their graduation date, the major before entering into the MAC graduate program, and the courses they are taking in the program. The student overview gave us the total credit hours they have taken, their total courses they've taken, the classes for either business, non-business, or accounting majors before entering into the program, and they also gave us the enrollment dates. We needed to develop a model that will make the data more organized and will make tracking students, classes, and schedules easier.
Here is the data model we came up with. On the left, the payment table can be linked to the student table by a one-to-many relationship, as one payment can belong to many students. The payment depends on the type of student. A student can be fully enrolled, dually enrolled, or a Xavier employee. The tuition depends on this. The student table consists of the student ID, student first and last names, their major, the payment ID, the type of student that they are, the hours required to graduate, the hours they have taken, and the hours they have left in order to graduate. The student table can then be linked to the schedule table by a one-to-many relationship, as one student will have many schedules in their career in the program. The schedule table consists of the schedule ID, a course ID, a student ID, MAC courses, which reflects the name of the course, and currently registered, which is a yes or no field that will determine whether a student is registered for a course in the current semester. The schedule table is then linked to the courses table by a many-to-one relationship, as one course will belong to many schedules. The courses table consists of a course ID, course name, course number, a level ID, which consists of 3 levels: lower, intermediate, and upper level courses, a course department, course teacher, a semester in which the course is offered, and number enrolled, which determines how many students will be enrolled in the course in a given semester. The courses table also has a recursive relationship with prerequisites, as one course can serve as a prerequisite for another higher level course, and that course can serve as a prerequisite for another higher level course.
The benefits of our data model. Our data model connects all aspects of students and courses. This means being able to see when a student can and should take a specific course, and whether the course is necessary for graduation will all be offered during the required semesters. Our data model can easily track which students have taken which classes and during what semester. And it's also easy to add in any future data that Dr. Maslach might gather through future enrolled students. It's able to track which classes are most popular given during the semester of offering, and can track which departments offer classes and how many students are and will enroll in each of these classes.
Here are some of the queries we ran in order to answer Dr. Maslak questions about the data model. In this case, we want to know which courses have more than one person enrolled in a class. This is a question that Dr. Maslak had in order to answer which questions or which courses should be offered during a given semester. He didn't want to offer any courses that were not going to have enough students in the class. So this will help in offering the right classes that have a certain amount of students enrolled in them. In this case, we select the course name from the courses table where the number enrolled is greater than or equal to 1. In this case, we see there's about 10 to 12 records of courses that have at least one student enrolled in them. In this case, Dr. Maslak would want to offer these classes so that all students enrolled will be able to take them and continue on their progress to graduation. We wanted to see which courses has a student Taylor Reed already taken and how many credit hours she has left. I want to remind you that all this data is fake data that we created in order to run these queries in order to show how efficient our data model is. In this case, we wanted to take the class name and the hours left from the classes and student tables. We wanted to match the SID to the name of Taylor Reed, which in this case happens to be the one shown on the screen. The query results in 3 classes that the student Taylor Reed has already taken, and it shows that she has 18 hours left in order to graduate. We wanted to see the tuition and undergraduate major of the student named Emily Sanders. This would help with just kind of see what type of student they are, how much they have to pay, and which kind of classes they have to take given their undergraduate major. In this case, we select the tuition and majors from the payment and student tables, respectively. We match student first and last name to Emily Sanders and link the table's payment and student through their PID. In this case, we see that the student Emily Sanders has a tuition of $50,000. This will probably lead us to think that she is a fully enrolled student. Then her major, education, gives us the major of her undergraduate studies. This will lead us to think that she will have to take the entire set of courses all the way from prerequisites in the business department all the way to MAC department classes. Which courses are offered only in the summer? This will help students who are working during the school year or have other plans throughout the school year in which they can only take classes throughout the summer months. Also, if a student specifically wants to take this course, they will have to see that it is only offered in the summer. We select the course ID and the course name from the courses table and limit the semesters offered to summer. In this case, we see that only one class is offered during the summer months. So if a student really wants to take this class, they will have to enroll for it during the summer months. How many non-business undergraduate major students are there in the program? This will help Dr. Maslak see what type of classes he will have to offer. Especially if they're non-business, he will have to offer the business prerequisites in order to enter the business core classes. We select Count Student ID as non-business from the student table and limit the type of student to non-business. In this case, we see that there are 2 non-business students. This means that they graduated with a non-business degree and will have to go through the entire process to graduate the MAC department. This query follows up with the previous query. What classes do non-business majors need to take throughout their career in the program? We select the schedule from the schedule table where the student ID is matched to that of a non-student. That means that they graduated with a non-business degree in their undergraduate studies. We see all of the classes that a non-business student will need to take throughout their career in the program. This means that a student that graduated with a non-business degree will have to take each and every one of these classes in order to go through the entire process and graduate. How many classes is each student currently enrolled in? This will help Dr. Maslak know how many students are currently enrolled in the program, as well as which classes they are currently enrolled in. We selected the student ID and counted currently registered from the schedule table. We limit currently registered to only yeses, as that will show us which classes they are currently registered for. We group by the student ID in order to have only one student ID given. The results show 10 students and anywhere from 1 to 3 classes in progress. The student ID can be matched to the student name, and the in progress will show how many classes they are currently enrolled in. What classes does each student have to take and when are they offered? This will help with advising, as an advisor will be able to see which classes a student has to take and when these classes are offered. Having known which classes a student has already taken, how many credit hours they have left, they can refer to this table and see which classes are left and when they will be able to take them in the coming months or semesters. We selected the student ID, the first and last name, the name of the course, and the course semester from the schedule, courses, and student tables. We then linked the schedule and courses tables through their CID and the schedule and student tables through the SID. In this case, we are given the student ID, their whole name, the name of the course, and the semester in which the class will be offered. For example, John Carlson will need to take about 6 classes in order to graduate. These classes are all offered anywhere from the fall to the spring to the summer, and the MBA elective is yet to be determined.
So this brings us to the question, why implement our database? So first, it's simple yet complex. It's easy to find and organize data, yet you can use complex queries like we have used to find data for students and for their semesters. Everything connects throughout the database. It's easy to retrieve and analyze the data. It incorporates both students and courses. It's easy to see what the students have taken, are taking, and will take. Also, it's able to see what teachers or what professors are teaching each course, and this will help to know the correct credit hours that students will need to take to graduate. It is also easy to add new data and modify existing records. Students will be coming through the program, they'll be graduating, we'll have newer people enrolling in the program, so we wanted to make this easy to access and easy to see how many credit hours they will need to graduate. And lastly, issues and recommendations. So first, with data security, wanted to make sure all the data is private. We don't want any of the data to be public. We want to keep it between the students, the faculty, and the university. And with the data integrity, we want to make sure it's all correct and honest data. We don't want students submitting wrong data, or when making the databases and data models, we don't want the faculty that enter the data to put in the data wrong, because that could cause a student to take more courses than they need or less than they need. And when it comes to graduation time, we want to make sure that everyone can graduate. So to make sure all the data is accurate. So to ensure this accuracy, we want to make sure we have more than one person to review the data. That way they can eliminate human error and they can make sure that these students are set and they can graduate on time.
Thank you for your time.